In this question, we are given that people enter a line for an escalator at a rate modeled by this function, and it's a non-zero between 0 and 300 seconds, and then after 300 seconds it's 0. And as people get on the escalator, the exit line is a constant rate of 0.7 persons per second, and initially there are 20 people in line. So the first question is how many people enter the line for the escalator during the time interval between 0 and 300. And so this is simply integral from 0 to 300 of r of t dt. And so we can write this down as integral from 0 to 300, 44 t over 100 to the third power 1 minus t over 300 to the 7th power dt. And we need a calculator to calculate that, and so let's do that next. So let's calculate this integral. It's mathematics integral from 0 to 300 seconds of the expression 44 times open parentheses t, or in this case x, it doesn't matter, t over 100 close parentheses to the power 3 open times open parentheses 1 minus x divided by 300 close parentheses to the power 7, and this is integral with respect to x. So enter, let's calculate what it is, and we see that there will be 270 people. They enter the escalator during this time period between 0 and 300 seconds. In this part of the question, we are given that during this time interval, there are always people in the escalator in line. And the question is how many people are in line at the time t equals 300. So we need this information that there are always people in order for us to realize that 0.7 persons per second always leave the escalator. Otherwise, the equation will be a little bit more complicated. But here is how we solve it. We need to have how many people were there initially, 20 people, plus all the people who entered the escalator. This is 0 to 300, RT dt, minus all the people who left the escalator, 0 to 300, this is 0.7 dt, and this is how we need to calculate it. So we calculated in part A that this is actually equal to 270, so we can do 20 plus 270 minus, and this is 0.7 t from 0 to 300. We can just calculate this without using a calculator. This is 0.7 times 300, which is 210, so this is 20 plus 270 minus 210, which is 80. So there will be 80 people in line at time t equals 300. In this part of the question, we are being asked what is the first time when there are no people in line for the escalator for t greater than 300. And we know that before t equals 300, there are always people in the escalator, on the escalator, because that's what we were answering in question B. So then we know that there are n of 300, and I denote n as a number of people is 80 from our previous question. And then from that point on, no people are getting in line for the escalator, right? But people are still living at a 0.7 person per second. So basically we need to divide 80 by 0.7, and that will give us the number of seconds, or how many seconds there will be past 300 that there will be no people on the escalator. So the answer is 300 plus 80 divided by 0.7, and you can use your calculator to calculate that this is 414.286 seconds, and this is our final answer. In this question we are being asked at what time t is the number of people in line a minimum for t between 0 and 300, and we need to find the number of people in line at that time. So let's write down the expression for the number of people. N of t equals to 20, which is the initial number of people at time 0, plus integral from 0 to t r of x dx, the number of people entering the line, minus integral from 0 to t 0.7 dx. And so this function is continuous and differentiable, so let's differentiate it. N prime of t is equal to, differentiate as r of t times the derivative of t with respect to t, which is 1, minus 0.7 times again the derivative of t with respect to t, which is 1. So this is equal to r of t minus 0.7. And so we need to find minimum or maximum, we need to find such t that this is equal to 0. And then compare the values of n at those point t with the end points between themselves and with the end point. So we need to compare it with n of 0, which is, we know, 20, and n of 300, which we calculated in the prior question, which is 80. And so we already can see that 300 is not a minimum, so because 80 is greater than 20. So we need to compare those t's between themselves and with 20. So let's use the calculator to find all those t's. So let's find all those values for which RT minus 0.7 is equal to 0. So we go to y and we enter this function, 44 times, open parentheses, x divided by 100, close parentheses, to the third power, times, open parentheses, 1 minus x divided by 300, close parentheses, to the 7th power, minus 0.7. And so we need to find zeros of this function. Let's go to window. Window is between 0 and 300. Let's make this step equal to 10. And let's grab this function. So we can see here that actually the derivative is negative up until some point, which seems to be between 30 and 40. Then it's positive, then again it hits 0 at some point here and becomes negative all the way to time equals 300. So this is the point of minimum, right? At time 0 the number of people is 20, then the number of people declines, then it hits minimum, then it starts increasing. This is a maximum, local maximum, and then it decreases to, at that point there are 80 people in line for the escalator. So really this is absolute minimum on this interval. So let's find this number. Let's look at window. Let's decrease it to between 30 and 40, and let's decrease this step to be 1, and let's graph it. So we see here that 0 is somewhere within this range. This is 0.33. So let's again change window. Let's do 32.9 and 33.1 with a step of 0.1. And if we didn't guess correctly, we can always change these limits to see where we are. And let's also decrease this range to negative 0.1 and 0.1. Let's graph it. So that we can see here 0 is slightly above 33. Let's do trace now and move to the right. We can see that the change is between 33,013 and 33,015. We can say it's 33,014. The answer is 33,014. So this is, we found time at which there is a minimum, and now we need to calculate the number of people in line at that time. Let's do that now. Now that we know t, let's calculate the number of people in line for the escalator at that time. So it's the number of people initially plus integral from 0 to 33.014. We calculated this number of 44 times x divided by 100 to the power cubed times, in parentheses, 1 minus x divided by 300, close parentheses, to the power 7, and then minus 0.7. That's the number, the rate at which people leave the line of x. And so now enter. It gives us that at that point there were 3.8 people, so approximately there were 4 people in line for the escalator. Thank you, and I will see you in the next video.